So in this recording, I'm going to take a deep dive into Swarm, which is a multi-agent framework that OpenAI released last Friday. So this is still an experimental and an educational framework. And so here it mentions it's currently an experimental sample framework intended to explore ergonomic interfaces for multi-agent systems. It is not intended to be used in production, therefore has no official support, right? But the implementation is interesting. It actually leverages function calling to stitch the agents together, which I'm not sure. If to me, when I look at multi-agent framework, I always think about microservices-based architecture. When I think about microservices architecture, I think about two patterns: the orchestration pattern and the choreography pattern. The stitching part of the agents in both these patterns are decoupled from the logic of the agents itself. But in Swarm, uh, the way I have seen it is like uh, the function calling method of stitching the agents makes agents and the stitching part of the agents all part of the same component, which I feel is this little uh, tight coupling between the two, but it's an interesting implementation. Right, so I'll show how this implementation uh, pattern works when I show a example of agent swap, right? So so it focuses on making agent coordination and execution lightweight, highly controllable, and easily testable. These are some of the characteristics of the framework. And there are two primitive abstractions that it uses. One is the agent itself and handoffs. Uh, so the handoff is where the function calling has been leveraged, and agent abstraction is the abstraction of the agent itself, right? Uh, so this is interesting. They define an agent in a very interesting way, that an agent encompasses instructions and tools and can at any point choose to hand off a conversation to another agent, right? Um, the other important thing that I wanted to highlight here is that it is a stateless pattern, and I wanted to find out. Okay, so here it says the Swarm's run function is analogous to the chat.completions.create function. In the chat completion API, it takes messages and returns messages and saves no state between calls. Importantly, however, it also handles agent function execution, handoffs, context variable references, and can take multiple turns before returning to the user. So some of the arguments that the run method of this framework takes is the initial agent that needs to be called, list of messages, context variables, and we'll show an use of this as well. Max turns, model override. So if there is a default model, if you want to override the default model is GPT-4o, right? We can override the model. Um, Execute tools. If false, interrupt execution and immediately returns tool calls message when an agent tries to call a function. We can turn on streaming, and we can also run it in debug mode, right? The response schema of the agent framework is messages. The last agent, or the active agent to handle a message, and the context variables. It also talks about the agent abstraction, which encapsulates a set of instructions and set of functions. So this is another interesting thing I noticed. While it's tempting to personify an agent as someone who does X, it can also be used to represent a very specific workflow or step defined by a set of instructions and functions. For example, a set of steps, a complex retrieval, single step of data transformation, etc. This allows agents to be composed into a network of agents, workflows, and tasks, all represented by the same primitive, right? And these are the agent fields, the name of the agent, the model that to be used by the agent, instructions, functions, and tool choice. Right? And yeah, so let's go into an example and see how this is implemented. Before that, I wanted to show this diagram to show like how actually the agents are stitched. So when a query is targeted towards an agent, right? The agent uh, says if it requires a function call, right? And if yes, the function call returns the next agent that needs to be handled, right? And the next agent then again checks if requires a function call. If not, then it ends the turn, right? So function calling is kind of stitching the agents together. So let's take a look at an example. So here I created this example 2, where I have 3 agents here, right? One agent is, so this is the math expert agent. You are an expert in maths and answer only mathematics questions. And then I have the physics expert agent. And then I have the entry agent, right? The first agent in the multi-agent system, which is responsible to route it to either the math agent or the physics agent based on the topic of the question, right? And to this agent, I pass 2 functions: ask math agent, ask physics agents, right? This is the function calling I was talking about, right? An ask math agent is nothing but this function which returns a math agent, and an ask physics agent is nothing but okay. So ask physics agent, this function which returns a physics agent. Ask math agent is the ask math agent function which returns a math agent, right? Then I okay. So the client is this is I create a client of Swarm. So if I go here, you'll see that this is what the client is, right? The get it has a get chat completion method, and I wanted to show the default model also. The default model is is in the client.run. The client.run is coded it here, right? So if I click on it, we should see the default model. Where did I see the default model? I think it is probably then in the Swarm. Let's see. Okay. Or okay, I know where it is. Like it is in the agent. Yeah, is an agent abstraction, right? This is where the default model is, right? And the default instructions are also there, which can be overridden, right? In the run, if I go inside the run now, we can see how it works, right? So the active agent, right? This is the first agent, right? When which gets called when I give the prompt. If I'm passing any context variables that like we do here, it does a deep copy of that, right? And puts into the history. And when the completion in the completion call, the get chat completion, if you remember, this is the swarm, the function that was in when we instantiated the client as swarm, right? There it passes the active agent, calls the completion message, right? If it is not a tool call, right? That means end of the turn, right? It has come to the end of agent call, right? It breaks. But if it is a tool call, then it gets the next agent, right? This is where it is getting the next active agent and then calling that agent again, right? That's how it is working. So let me run this and it will be clear. I put some print statements within this code to show how the flow works. So here I put the print active agent one. This is the first agent. Wanted to also see the context, how the context variables flow, right? And then here I put the active agent two, right? And then finally, like, since I have three agents, right? So active agent one um, would be like it will call the agent A, and then based on whether physics or maths, it will go to the physics or the maths agent. Let me run this. So, by the way, the context variable, right? I'm passing past conversation, like the conversation I'm doing, right? I'm pushing it to the context variable here by doing an context dot append. And here in my user query, I append that context variable so that when it answers, it has the history of the conversation history, right? So let's just say what is reflection, right? So here you'll see the chat completion message, right? It passes or it has a function calling ask physics agent, right? It, right. So this is based on the topic, right? It says, okay, ask physics agent is a function call. It hands it over to the physics expert, right? So I get the physics expert. The physics expert, there will be no function call. That means it is the end of the turn, right? So if I go here, yeah, function call equal to none, tool call equal to none. That is the end of the turn, right? For that particular thing, it answered me that reflection is the phenomenon that occurs when a wave such as light, right? What it gave me the answer, right? Then I say, what is 30 multiplied by 40? Now it should hand it over to the math agent, right? So if I see now the chat completion agent, the function call ask math agent, right? And the ask math agent gave me the answer. The past history, if you say it is adding since I have concatenated the response dot context variable, right? It is, and the context variable is where I am appending each response that I get in every turn, right? So it is storing the past conversation here, right? And if I see, say, what questions have I asked? Try this. Sometimes it is able to actually refer to it. Sometimes it hallucinates, but let's see. Yeah. So see here it has hallucinated. What you have not asked any direct question so far. The past includes an explanation about reflection. Kind of it still says it, but in one of the tries, it actually said, okay, you asked these questions. So probably some more prompt tuning will be required, but it was able to, since I passed the history, it is able to say the past conversation includes an explanation about reflection, but no specific questions are mentioned, which is partially true, partially like I did ask about reflection, but yeah, I asked the question also, right? So this is how it works. As the GitHub also mentioned that this is still it is an experimental and educational type of framework, um, and my observation on it is that the stitching part of the agents are still um, tightly coupled within the framework. If we follow a microservices-based architecture, my services and the orchestration of the services needs to be decoupled so that we have more control on changing or adapting to new changes and all, right? Kind of the way LangGraph does it, right? Where LangGraph is the orchestration, and I can orchestrate with a LLM-based agent or a non-LLM-based agent using the orchestration. It's similar to how we used to do microservices-based development, where for choreography, we used to use event hubs like Kafka. For orchestration, uh, tools like Camunda or Pega or any Airflow, right? Used to orchestrate the services. I will keep an eye on this particular framework and see how it develops, right? If there are certain interesting things, interesting features it gets, I am going to keep an eye on it, read about it, and share at the right time. Thank you. Bye-bye.